Imagine that everything you have ever seen in the night sky, every star, every glowing dot, every flicker, is not even a speck of dust on the surface of what actually exists. Right now, while you listen to these words, our galaxy is hurtling through the void at a speed of more than 2 million kilometers per hour, and we feel absolutely nothing. We are flying into the unknown, and no one knows exactly where. Here is a fact that will change your perception of reality forever. If you could travel at the speed of light, the highest speed possible in the universe, the speed at which photons from distant stars move, it would take you 100,000 years just to cross our galaxy from one edge to the other. Not the universe, not a cluster of galaxies, just our small, ordinary, unremarkable Milky Way. 100,000 years at a speed of 300,000 kilometers per second. And that is not even the most frightening part. Today we will dive into 3 mysteries that haunt astronomers around the world. First, why did our galaxy turn out to be exactly this size, and what does this say about the laws governing the cosmos? Second, what lies beyond the space visible to us, and why will we never be able to get there? Third, what place does the Milky Way occupy in the hierarchy of the universe? And how lonely are we really in this abyss? By the end of this journey, you will learn something that will not let you sleep peacefully. You will understand how fragile our existence is, how accidental our appearance here is, and how vast the gap is between what we know and what we have yet to understand. This knowledge will change you. It will make you look at the stars differently every time you look up at the night sky. If you are fascinated by the mysteries of space, subscribe to the channel. The journey begins right now. When we were children, we were told a simple and beautiful story. Our planet rotates around the sun. The sun is a star, one of many. All these stars together form a galaxy called the Milky Way. And beyond our galaxy, there are other galaxies. And all together, they make up the universe. A simple scheme, a clear picture, a cozy explanation. We were shown beautiful images of spiral galaxies resembling cosmic pinwheels. We saw the Milky Way as a glowing band in the night sky and thought we understood our place in the universe. Teachers told us that our galaxy contains about 100 billion stars, and this seemed like an unimaginably large number. We imagined space as something vast, but still comprehensible to the human mind. This picture of the world was comforting. It created the illusion that we understood the scales of what we exist in, that the universe is just a very large room, and we are small but important inhabitants of this room. That science has already solved the main mysteries of space, and we only have to clarify the details. But reality turned out to be completely different, and it is much more frightening. Modern research shows that everything we were told is only a tiny part of the truth, simplified to such an extent that it practically ceases to be true. Our galaxy is not just big, it is so huge that the human brain is physically incapable of realizing its true dimensions. And yet, here is the horror. It is one of the most ordinary, unremarkable galaxies in the universe. Let's start with a simple number. The diameter of the Milky Way is approximately 100,000 light years. But what is a light year? It is the distance that light travels in 1 year, moving at a speed of almost 300,000 kilometers per second. In 1 second, light flies a distance equal to almost 8 revolutions around the Earth. In a minute, 18 million kilometers; in an hour, more than 1 billion kilometers; in a day, almost 26 billion kilometers; in a year, about 10 trillion kilometers. Now multiply this by 100,000. You get a number so large that it is impossible to imagine. This is approximately 950 quadrillion kilometers, 950,000 trillion. If you tried to count the kilometers at the same speed you count seconds, it would take you 30 million years just to say the whole number. This is only the diameter, the flat part of the galactic disk. But the Milky Way is not a flat object. It is a complex three-dimensional structure with a central thickening called the bulge, with spiral arms, with a giant spherical halo of dark matter that extends far beyond the visible part of the galaxy. Recent studies have shown that the real dimensions of our galaxy are significantly larger than previously thought. The dark matter halo surrounding the Milky Way extends to a distance of about 600,000 light-years from the center. This means that the total diameter of our galaxy, taking into account the invisible dark matter, is more than 1 million light-years. 1,000,000 years at the speed of light. Try to realize this. The fastest spacecraft ever created by humanity, the Parker probe, which explores the Sun, develops a speed of about 700,000 kilometers per hour. This is incredibly fast by human standards, but even at such a speed, crossing only the visible disk of our galaxy would take more than 150 billion years. This is 10 times more than the age of the universe itself. We are trapped here forever. But wait, we are just beginning to dive into the abyss because size is only the first layer of this story. Much more interesting is what is inside this space and how it is organized. The Milky Way contains from 200 to 400 billion stars. This number in itself is incomprehensible. If you counted one star per second, without stopping for sleep, food, or anything else, it would take you more than 12,000 years to count them all. And these are only stars. Not planets, not asteroids, not comets, not clouds of gas and dust. According to modern estimates, there may be up to 100 billion planets in our galaxy. Some studies suggest that this number could reach 400 billion. On many of these planets, conditions suitable for life may exist, but we will never know for sure. The distances are too great, time is too short. Our life is but a moment on the scale of the cosmos. And here is what truly strikes the imagination. Despite all these hundreds of billions of stars, our galaxy is mostly emptiness. The average distance between stars in our neighborhood of the galaxy is about 5 light-years. This is approximately 50 trillion kilometers of absolutely empty space between each pair of neighboring stars. Imagine this. If the Sun were the size of a pea, the nearest star, Proxima Centauri, would be at a distance of more than 300 kilometers, 300 kilometers of emptiness between two peas. And this is the nearest star. Most of the stars in our galaxy are much farther from each other. A galaxy is not a dense cluster of matter. It is an ocean of emptiness, with rare islands of light scattered over unimaginable distances. And we, the inhabitants of one of these tiny islands, are lost in the boundless darkness. But reality is even more frightening than just emptiness. Everything we see, all these stars, planets, gas clouds, all the matter of which we ourselves consist, is only about 5% of what actually exists in the universe. The remaining 95% is something we do not understand. We call it dark matter and dark energy, but these names are only an admission of our ignorance. Dark matter makes up about 27% of the universe. We cannot see it, we cannot touch it, we cannot detect it directly. But we know it exists because we see its gravitational influence. It is dark matter that keeps galaxies from falling apart. Without it, stars on the outskirts of galaxies would fly off in different directions like stones from a sling. Our galaxy is literally immersed in an ocean of invisible substance that we do not understand. We swim in it like fish in water, without realizing its presence. And this substance determines the shape of our galaxy, its dimensions, its evolution. We exist thanks to something about which we know practically nothing. Another 68% of the universe consists of dark energy, a force that causes the universe to expand at an ever-increasing speed. This force works against gravity, tearing the fabric of space, increasing the distance between galaxies. And we have not the slightest idea what it is. It turns out that we live in a galaxy that consists predominantly of matter about which we know nothing, in a universe governed by a force that we do not understand. And with all this, we consider ourselves intelligent beings, capable of understanding the organization of the cosmos. There is something simultaneously funny and tragic in this. Let's return to the visible part of our galaxy and try to understand its structure. The Milky Way is a barred spiral galaxy. This means that in its center there is an elongated structure of stars, the so-called bar, from which spiral arms depart. Our solar system is located in one of these arms, the Orion arm, which is sometimes called the local spur. We are located approximately at a distance of 26,000 light-years from the center of the galaxy, which is approximately half the radius of the visible disk. This is neither the center nor the outskirts. We are somewhere in the middle, in a fairly quiet region of space. And this is perhaps the only reason why we exist. The center of the galaxy is a place of unimaginable violence and chaos. There is a supermassive black hole that we call Sagittarius A. Its mass is about 4 million masses of the Sun, compressed into a space that could fit inside the orbit of Mercury. Stars revolve around it at incredible speeds. Some of them fly past the black hole at a speed of several % of the speed of light. Radiation in the center of the galaxy is so intense that any planet ending up there would be sterilized in a matter of moments. Life in that region of space is impossible. Too much radiation, too many gravitational disturbances, too many catastrophic events. On the outskirts of the galaxy, the situation is different, but not better. There are too few heavy elements: carbon, oxygen, iron. All that planets and living organisms consist of. These elements are formed in the depths of stars and scattered during supernova explosions. On the outskirts of the galaxy, there are fewer stars, fewer supernovas, and, consequently, less building material for life as well. We are located in the so-called galactic habitable zone, a narrow strip of space where conditions are favorable enough for the existence of complex life. Not too close to the deadly center, not too far on the poor outskirts. An ideal place. Too ideal to be a coincidence. Or is it? This question remains open. Science does not know the answer. Now let's rise even higher and look at our galaxy from the side. What will we see? We will see a majestic spiral, slowly rotating in the void of space. Its spiral arms are density waves, areas where gas and dust are compressed, forming new stars. These arms are not permanent structures. They are like waves on water that pass through the matter of the galaxy. Creating temporary concentrations, our solar system completes a full revolution around the center of the galaxy in approximately 230 million years. This period is called a galactic year. During the existence of the Earth, approximately 4.5 billion years, our planet has made about 20 revolutions around the galactic center. 20 galactic years. This is everything that has been in the history of our planet. Dinosaurs appeared and became extinct in less than 1 galactic year. All of humanity, from the first ape-like ancestors to modern civilizations, has existed for only a tiny fraction of 1 galactic year. We are a moment in the life of the galaxy. A flash, a spark, possibly already extinguished by the time you listen to these words, and the galaxy will continue to rotate after us. It will not even notice our disappearance. But that is not all, because our galaxy is not alone in the universe, and here the story becomes truly frightening. The Milky Way is part of a group of galaxies that we call the local group. This group contains more than 50 galaxies of various sizes, gravitationally bound to each other. The largest members of this group are our galaxy and the Andromeda Galaxy, also known as Messier 31. The Andromeda Galaxy is larger than ours. Its diameter is about 220,000 light-years, more than twice the size of the Milky Way. It contains about 1 trillion stars, at least twice as many as our galaxy, and it is moving directly towards us. Right now, at this very moment, the Andromeda Galaxy is approaching the Milky Way at a speed of about 400 kilometers per second. This is more than 1,000,000 kilometers per hour, and in 4.5 billion years, these two galaxies will collide. A collision of galaxies is not an instantaneous catastrophe, but a slow dance of gravitational forces stretched over hundreds of millions of years. Stars and galaxies are located so far from each other that direct collisions between them are extremely unlikely. But gravitational tidal forces will mix both galaxies, distort their spiral structures, and throw billions of stars into intergalactic space. Ultimately, both galaxies will merge into one giant elliptical galaxy, which astronomers have already nicknamed Milky Way. Our Sun, if it still exists by then, could end up at any point in this new galaxy, possibly even thrown into the cold void between galaxies. But we will no longer be there. In 4.5 billion years, the Sun will turn into a red giant and swallow the inner planets of the solar system. By then, the Earth will have long been a dead, scorched, expanding star. Perhaps humanity will have time to move to other planets or other star systems. Perhaps not. We do not know. And this is not the end of the story, because the local group is only a tiny part of an even larger structure. Our group of galaxies is part of the Virgo supercluster, a giant collection of thousands of galaxies stretching for 110 million light-years. And the Virgo supercluster, in its turn, is part of an even larger structure, Laniakea. Laniakea, translated from Hawaiian, means immeasurable heaven. It is a giant cosmic complex containing about 100,000 galaxies and stretching for 520 million light-years. The mass of Laniakea is about 100 quadrillion masses of the Sun. All these galaxies are moving in the direction of a mysterious gravitational attractor called the Great Attractor, a region of space whose nature is still not fully understood. And even Laniakea is not the end. Beyond its boundaries stretch other superclusters, other cosmic structures, going further and further into infinity. The observable universe has a diameter of about 93 billion light-years and contains, according to various estimates, from 200 billion to 2 trillion galaxies. 2 trillion galaxies. Each, well, like our Milky Way or larger. Each contains hundreds of billions of stars. Each an abyss of space and time about which we know almost nothing. And this is only the observable universe, what we can see. Light from more distant objects has not yet had time to reach us during the existence of the universe. What lies beyond the observable universe we do not know. We will never know. The expansion of space occurs faster than the speed of light, and information from these regions will never reach us. We are trapped in a bubble of light surrounded by infinite unknown. And now, when we understand the scales of what surrounds us, let's return to our small galaxy and look at it with new eyes. The Milky Way is a grain of sand, a tiny, insignificant dot in the boundless ocean of the cosmos. All our wars, all our achievements, all our fears and hopes, all this happens on one small planet rotating around one ordinary star in one unremarkable galaxy lost in the abyss of the universe. And yet, here is what is amazing. This tiny galaxy contains everything we have ever known. All the people who ever lived looked at the same stars. All of human history unfolded against the background of the same night sky. And all our dreams of the future are connected to this same galaxy because we will most likely never be able to leave it. The distances are too great. Time is too short. Physics is too cruel. But perhaps there is its own beauty in this. Perhaps the realization of our insignificance is not a reason for despair, but an invitation to humility. We are part of something unimaginably large and complex. We are the way the universe knows itself. We are stardust that has gained consciousness and the ability to ask questions. And even if we never find the answers, the very fact that we can search for them makes us special. Now that we have realized the scales of our galaxy and its place in the cosmic hierarchy, let's descend deeper. Let's look at those forces and phenomena that make the Milky Way not just big, but a truly frightening place, because size is only the beginning. Behind the beauty of the spiral arms and the flickering of distant stars hides something much darker and more dangerous. Let's start with what is at the very heart of our galaxy. There, 26,000 light-years from us, a monster lies in wait. The supermassive black hole Sagittarius A is not just a cosmic object. It is the embodiment of what happens when the laws of physics reach their limits and break. A black hole is a region of space where gravity is so strong that even light cannot leave it. Imagine this. Light is the fastest thing in the universe, a fundamental courier of information in the cosmos, and it ends up trapped forever. Nothing can escape from beyond the event horizon. Neither matter, nor energy, nor information. It is a one-way door to nowhere. The mass of Sagittarius A is about 4 million solar masses. To understand how much that is, imagine 4 million stars like our Sun compressed into a point the size of less than Mercury's orbit. The density of matter in such an object exceeds everything we can imagine. The laws of physics that we know cease to work in such conditions. And this black hole is not static. It actively absorbs matter from the surrounding space. Gas, dust, sometimes entire stars fall into its insatiable maw. When matter approaches the event horizon, it accelerates to incredible speeds, heats up to millions of degrees, and emits powerful radiation. This radiation we can observe even from Earth, despite the monstrous distance. In 2019, scientists for the first time obtained an image of the shadow of a black hole in the center of another galaxy, Messier 87. This image showed us a ring of red-hot gas surrounding absolute darkness. Darkness from which there is no return. It was one of the most frightening and at the same time beautiful shots in the history of science. But Sagittarius A is not the only black hole in our galaxy. According to modern estimates, the Milky Way may contain up to 100 million black holes of stellar mass, the remains of massive stars that ended their lives in catastrophic collapse. These objects are scattered throughout the galaxy, invisible and deadly dangerous. Most of them we cannot detect directly because they do not emit light. We know about them only when they interact with visible matter, absorb gas from a neighboring star, or distort the light of distant objects with their gravity. How many black holes wander in space unnoticed, we do not know. One of them may be located much closer to us than we think. And here is what is truly frightening. If a black hole of stellar mass approached our solar system, we would find out about it too late. It would be invisible until it began to disturb the orbits of the planets. By that moment, it would be too late to do anything. Our system would be torn apart by gravitational forces. Planets thrown into interstellar space or absorbed by the black abyss. The probability of such an event is extremely small, but it is not equal to zero. In a galaxy containing 100 million wandering black holes and 200 billion stars, statistics become our only defender. We are alive only because so far we have been lucky. But black holes are only one of the sources of danger in our galaxy. There are other no less destructive phenomena. Supernova stars. When a massive star exhausts its nuclear fuel, it undergoes a catastrophic collapse, followed by a monstrous explosion. In a fraction of a second, more energy is released than our sun will produce in the entire time of its existence. The brightness of a supernova can exceed the brightness of an entire galaxy. It is one of the most powerful explosions in the universe. In our galaxy, supernovas flare up approximately once every 50 years. Most of them occur in distant regions of the Milky Way, hidden from us by clouds of gas and dust. But sometimes they happen close enough to be visible to the naked eye. The last such supernova was observed in 1604, Kepler's supernova. Since then, more than 400 years have passed, and we, statistically speaking, have long been waiting for the next one. What will happen if a supernova flares up close to Earth? This depends on the distance. At a distance of less than 50 light-years, the consequences could be catastrophic. A stream of gamma radiation and cosmic rays will destroy the ozone layer, leaving the surface of the planet defenseless against the ultraviolet radiation of the sun. Mass extinction will become inevitable. Are there stars ready to explode so close to us? Yes. Betelgeuse, a red supergiant in the constellation Orion, is at a distance of about 700 light-years and can explode at any moment, tomorrow or in 100,000 years. This is far enough not to pose a direct threat, but close enough to put on an impressive celestial show. For several weeks, Betelgeuse will become so bright that it will be visible even during the day. But there are other candidates. Eta Carinae, a hypernova star at a distance of about 7,500 light-years, is one of the most unstable stars in our galaxy. When it explodes, it will be one of the most powerful explosions in the history of the Milky Way. Fortunately, its axis of rotation is not directed at Earth, so the deadly gamma-ray burst will pass us by. Fortunately, this word we use too often when speaking of cosmic threats. All our security is based on luck and statistics. We live in a galaxy full of deadly dangers, and the only thing that protects us is the incredible distances between objects and the randomness of our location. But even distances cannot protect us from everything. Gamma-ray bursts are the most powerful explosions in the universe, surpassing even supernovas. They occur when massive stars collapse into black holes or when neutron stars collide. In a few seconds, a gamma-ray burst emits more energy than the sun in 10 billion years. If a gamma-ray burst occurred in our galaxy and were directed at Earth, the consequences would be apocalyptic. The atmosphere would be ionized, the ozone layer destroyed, the surface of the planet sterilized. Life as we know it would cease to exist in a matter of minutes. Some scientists suggest that it was a gamma-ray burst that could have caused one of the mass extinctions in Earth's history. The Ordovician-Silurian extinction, about 450 million years ago. There is no direct evidence, but the hypothesis remains plausible. We do not know how many times life on Earth has been on the brink of complete destruction due to cosmic catastrophes. And we will not know about the approaching danger in advance. Gamma radiation moves at the speed of light. We will see the flash at the same moment it hits us. There will be no warning. There will be no time for preparation. Just a bright flash in the sky and the end of everything. This knowledge should frighten us, but it should also remind us of the fragility of our existence and of the incredible luck that allowed us to appear and exist for so long. Let's talk about another aspect of our galaxy, its dynamics and evolution. Because the Milky Way is not a static object. It is a living, constantly changing system. And these changes are sometimes catastrophic. Our galaxy is a cosmic cannibal. Throughout its history, it has absorbed many smaller galaxies, tearing them apart with its gravity and absorbing their stars. Traces of these ancient mergers are still visible in the structure of the Milky Way. Streams of stars with abnormal orbits, the chemical composition of some stars not matching the rest of the galaxy. One of the largest mergers occurred about 10 billion years ago when the Milky Way collided with a galaxy that astronomers call Gaia Enceladus. This galaxy was about 4 times smaller than ours, but the collision was still catastrophic. It changed the structure of the Milky Way, added billions of new stars, and possibly launched a new wave of star formation. Right now, our galaxy is in the process of absorbing several dwarf galaxies. The most famous of them is the Sagittarius dwarf spheroidal galaxy, which has already passed through the disk of the Milky Way several times and is gradually being torn apart. Its stars form a long stream encircling our galaxy, a trail of cosmic destruction stretching for hundreds of thousands of light-years. The Large and Small Magellanic Clouds, 2 dwarf galaxies visible to the naked eye from the southern hemisphere, are also doomed. They are slowly falling onto the Milky Way and will ultimately be absorbed. This process will take billions of years, but it is inevitable. Our galaxy is hungry, and it continues to grow at the expense of its smaller neighbors. And, As we have already said, the main event is still ahead. The collision with the Andromeda Galaxy will completely change the appearance of our cosmic home. Two great spirals will merge into one giant elliptical galaxy, and nothing that we know today will remain. But there is something else that is rarely spoken of. Something that makes our position in the galaxy even stranger and possibly more frightening. Our solar system has not always been where it is now. Throughout the 4.5 billion years of its existence, it has made about 20 revolutions around the center of the galaxy, but its orbit was not ideally stable. Gravitational disturbances from other stars, from spiral arms, from massive molecular clouds. All this gradually changed the trajectory of our movement. Some studies suggest that the solar system could have migrated a significant distance from its place of birth. Perhaps we formed closer to the center of the galaxy in a denser and more active region, and then were thrown into a quieter orbit. If this is so, then we owe our existence to this migration. In the original place of birth, conditions could have been too harsh for the development of life. This is another layer of randomness in our existence. We did not just end up in the right place in the galaxy. We were moved there by cosmic forces that we do not control and do not understand. But let's rise even higher and look at an even more large-scale picture. Because even our position in the galaxy is only part of a more grandiose story about our place in the universe. The Milky Way is moving, not just rotating around its center, but moving as a whole through the space of the universe. We are hurtling through the cosmos at a speed of about 600 kilometers per second, more than 2 million kilometers per hour in the direction of the mysterious Great Attractor. The Great Attractor is a gravitational anomaly located at a distance of about 250 million light-years from us in the direction of the constellations Centaurus and Hydra. Its mass is equivalent to approximately 10,000 masses of the Milky Way, concentrated in a relatively small area of space. It attracts to itself not only our galaxy, but thousands of other galaxies in our part of the universe. What is at the center of the Great Attractor? We do not know exactly. This region of space is closed from our view by the plane of the Milky Way, the so-called zone of avoidance, where the dust and gas of our galaxy block the light from distant objects. We know that a cluster of galaxies is located there, but the full picture remains hidden. And here is what is interesting. Despite the fact that we are moving towards the Great Attractor, we will never reach it. The expansion of the universe works against us. The space between us and the attractor is increasing faster than we are approaching it. We are chasing a horizon that is always receding. This is one of the strangest and most counterintuitive features of our universe. Galaxies can move towards each other under the action of gravity, but the space between them is expanding. At sufficiently large distances, expansion wins, and objects move away from each other despite mutual attraction. In the distant future, in trillions of years, the expansion of the universe will isolate our local group of galaxies from the rest of the cosmos. All galaxies beyond our cluster will disappear beyond the cosmic horizon, carried away by the expanding space. The sky will become dark. The universe will seem small and empty. Any civilization existing in that distant time will not know about the existence of other galaxies. For them, the universe will consist of only one giant galaxy, the result of the merger of all members of the local group, surrounded by infinite emptiness. They will not even be able to imagine the splendor that we see today. We live in a special time, a time when the universe is still young, when galaxies are still visible, when the cosmos is still full of light and movement. In trillions of years, all this will end. Stars will go out, galaxies will decay, and the universe will plunge into eternal darkness. But this future is so distant that it is almost pointless to talk about it. 1 trillion years is a number that the human mind is incapable of realizing. The entire history of the universe from the Big Bang to today is only about 14 billion years. 1 trillion is 70 times more. It is an eternity measured in human terms. Let's return to closer timescales and talk about what might happen to our galaxy in the foreseeable future. Because even in the next billions of years, dramatic changes await us. First of all, our galaxy will continue to form new stars. In the spiral arms of the Milky Way are giant clouds of gas and dust, so-called molecular clouds, where new stars are constantly being born. Every year, approximately 3 new stars appear in our galaxy. This may seem like a small number, but over billions of years it adds up to a significant value. However, the reserves of gas in the galaxy are not infinite. Each new star takes part of this gas, turning it into dense stellar matter. When stars die, part of the substance returns to the interstellar medium. But not all. Part is forever locked in white dwarfs, neutron stars, and black holes. The galaxy is gradually drying up. According to astronomers' estimates, the reserves of gas in the Milky Way will last for approximately another 5 billion years of active star formation. After this, the formation of new stars will sharply slow down. The galaxy will begin to age. Bright blue stars, the most massive and short-lived, will go out first. Only small red dwarfs, capable of shining for trillions of years, will remain. But by then, the merger with Andromeda will have occurred, which could change everything. A collision of galaxies often causes bursts of star formation when gas clouds collide and compress. Perhaps the merger will give our galaxy a new youth, a new generation of bright stars. Or perhaps not. We cannot know for sure. Simulations show different scenarios, and reality may differ from all our predictions. The future of the galaxy is as uncertain as our own future. And in this uncertainty, there is something simultaneously frightening and liberating. We do not know what will be. We do not control the cosmic forces governing our fate. We can only observe, study, and try to understand. And perhaps in this is the meaning of our existence. Not in control over the universe, but in its contemplation. Not in the conquest of space, but in admiration for its greatness. We are witnesses. We are those who look and are amazed. And this in itself is an incredible privilege, because a large part of the universe, dark matter, dark energy, the empty space between galaxies, will never know that it exists. Only we, tiny creatures on a tiny planet, are capable of realizing the scale of what surrounds us. Only we can ask questions and search for answers. This makes us, with all our insignificance, something special, something unique in this boundless darkness. But let's not get ahead of ourselves. We still have many topics for discussion, many mysteries, many secrets, many questions without answers. The journey continues. Now let's talk about something that is rarely discussed in popular documentaries about space, about what happens between the stars, about the emptiness that makes up most of our galaxy. Because it is this emptiness that is the key to understanding the true scales of the Milky Way. When we look at the night sky, we see stars, thousands of bright dots scattered over the black velvet of the cosmos. Our brain automatically fills the gaps between them, creating the illusion of a relatively dense stellar field. But this illusion is deceptive. What we perceive as a sky strewn with stars is only the thinnest veil of light cast over the bottomless abyss of emptiness. Interstellar space is not just an empty place between stars. It is a medium so rarefied that our best vacuum chambers on Earth seem overcrowded with matter in comparison with it. In the deepest vacuums that we can create in the laboratory, there are still about 1 million molecules per cubic centimeter. In interstellar space, this number falls to 1 molecule per cubic centimeter, and in the space between galaxies, to 1 molecule per cubic meter. Imagine a cube with a side of 1 meter, approximately the size of a small refrigerator. In this volume of intergalactic space, there is on average 1 atom. 1. Everything else is absolute emptiness. Nothing, not even a vacuum in the usual sense, but something even emptier than we can imagine. And here is what strikes the imagination. This emptiness is not dead and not static. It is permeated with fields, gravitational, electromagnetic, dark matter fields. Cosmic rays, high-energy particles accelerated to speeds close to light, hurtle through it. Neutrinos, ghostly particles that almost do not interact with matter, cross it. Every second, trillions of neutrinos from distant stars pass through your body, and you feel nothing. Interstellar space is not emptiness in the philosophical sense. It is an arena in which cosmic dramas of unimaginable scales are played out. It is the medium through which gravitational waves from colliding black holes propagate. It is the ocean in which our cosmic islands float, stars, planets, galaxies, and the dimensions of this ocean defy comprehension. Let's try one thought experiment. Imagine that you want to create a scale model of our galaxy in which the sun will be the size of a grain of sand with a diameter of 1 millimeter. How large should such a model be? In reality, the diameter of the sun is about 1,400,000 kilometers. If we reduce it to 1 millimeter, then the scale of our model will be approximately 1 to 1.5 trillion. In this scale, the Earth will be the size of a microscopic dust mote about 1/10 of a millimeter, at a distance of about 10 centimeters from the sand-grained sun. Pluto, the farthest object that most people consider part of our solar system, will turn out to be at a distance of about 4 meters from the sun. Our entire solar system will fit in a medium-sized room. And now the nearest star. Proxima Centauri in this scale will be another grain of sand, located at a distance of about 30 kilometers. 30 kilometers of emptiness between two grains of sand. This is the distance from the center of an average city to its suburbs, and this is the nearest star. And the entire galaxy in our scale, where the sun is a grain of sand of 1 millimeter, the diameter of the Milky Way will be about 7 million kilometers. This is approximately 5 times the real diameter of the sun. A model of the galaxy on the scale of a grain of sand will not fit on Earth. It will not even fit between the Earth and the Moon. It will be larger than the distance from the Sun to Mercury. And at the same time, remember, this whole model will be almost completely empty. 200 billion grains of sand scattered at distances of tens of kilometers from each other, in a sphere with a diameter of 7 million kilometers. If you started looking for even one grain of sand at random, you would never find it. The emptiness is overwhelming. Matter is a rare exception. This is the true scale of our galaxy. Not a cluster of stars, but a boundless desert with rare oases of light. Not a house full of residents, but infinite darkness with sparks scattered in it. And we are on one of these sparks, lost in the abyss. Now let's rise even higher and look at the structure of the galaxy itself in more detail. Because the Milky Way is not just a disk with spiral arms. It is a complex, multi-layered system, full of mysteries and anomalies. The central part of our galaxy, the so-called bulge, is a giant spherical thickening consisting predominantly of old stars. These stars formed in the first billions of years of the galaxy's existence, when conditions were completely different. They are poor in heavy elements, because then the universe had not yet had time to be saturated with the products of stellar explosions. The diameter of the bulge is about 10,000 light-years. This is about 10% of the diameter of the entire galactic disk. But the density of stars in the bulge is much higher than in our region of the galaxy. If the Earth were in the center of the galaxy, the night sky would be strewn with such a number of stars that the night would be almost as bright as the day. Thousands of stars would be visible to the naked eye, and the Milky Way would shine with a dazzling light. But life there would be impossible. Too much radiation, too many gravitational disturbances, too many chaos. Around the bulge stretches the galactic disk, a flat structure about 1,000 light-years thick, containing most of the stars, gas, and dust of the galaxy. It is in the disk that the famous spiral arms of the Milky Way are located. For a long time, astronomers argued about the number and structure of the spiral arms of our galaxy. The problem is that we are inside the disk, and it is difficult for us to see the general picture, as it is difficult for a fish to describe the shape of an aquarium from the inside. Only in recent decades, thanks to infrared observations and precise measurements of distances to stars, have we begun to understand the true structure of our home. Today, it is believed that the Milky Way has 4 main spiral arms: the Perseus arm, the Scutum Centaurus arm, the Sagittarius arm, and the outer arm. Our solar system is located in a small branch between the Perseus and Sagittarius arms, which is called the Orion arm or the local arm. Spiral arms are not permanent structures. They do not rotate together with the galaxy like a rigid body. Instead, they represent density waves, areas where gas and stars are temporarily compressed, much like cars slow down and pile up in front of a traffic light. Stars enter the arm from one side, pass through it, and exit from the other side. Arms are not things, but processes. When gas clouds enter a spiral arm, they are compressed under the action of increased density. This compression launches the process of star formation. Therefore, spiral arms are places where new stars are born. Bright blue giants, living only a few million years, have time to live their entire lives without leaving the arm in which they were born. This is why spiral arms stand out so brightly in images of galaxies. They are highlighted by young hot stars. But above and below the galactic disk stretches another structure, the stellar halo. This is a spherical region containing the oldest stars of the galaxy, as well as globular clusters with a dense group of hundreds of thousands of stars gravitationally bound to each other. Globular clusters are true relics of the ancient universe. Many of them formed more than 12 billion years ago, when our galaxy was still only forming. They survived all the cataclysms, all the mergers, all the changes that happened with the Milky Way throughout its history. They are witnesses of cosmic history, storing information about the past in themselves. About 150 globular clusters are known in our galaxy, but their real number may be much larger. Many of them are hidden behind the dust clouds of the galactic disk, or are in regions that we have not yet studied in sufficient detail. And finally, the most mysterious part of our galaxy is the dark matter halo. It extends far beyond the visible part of the galaxy, forming an invisible sphere with a diameter of more than 1,000,000 light-years. The mass of this halo exceeds the mass of all visible matter in the galaxy by several times. We do not know what dark matter consists of. We cannot see it. We cannot detect it directly. But without it, the galaxy could not exist in the form in which we observe it. The speeds of rotation of stars on the outskirts of the galaxy are too high. Without additional gravity from dark matter, they would have long ago flown off in different directions. Dark matter is the framework on which our galaxy rests. It is the skeleton of the cosmos, and we do not know what it is. There are many theories. Some scientists suggest that dark matter consists of as yet undiscovered particles, WIMPs, or axions. Others believe that it could be primordial black holes formed in the first moments after the Big Bang. Still others allow that we need to revise our theories of gravity, but none of these hypotheses has received final confirmation. We build huge detectors deep underground, protected from cosmic radiation, hoping to catch at least one particle of dark matter. So far, unsuccessfully. The secret remains unrevealed, and this reminds us of how little we actually know. We are proud of our science, our technologies, our understanding of the universe, but 95% of what the cosmos consists of remains a mystery to us. We see only the tip of the iceberg floating in the ocean of the unknown. Let's now talk about time, because size is only one dimension of the greatness of our galaxy. Time is another, no less striking. The age of the Milky Way is estimated at approximately 13 billion years. This is almost as much as the age of the universe itself. Our galaxy is one of the first large structures formed after the Big Bang. It saw the birth of the first stars, the first supernovas, the formation of the first planets. 13 billion years. How to realize such a span of time? Let's try to compress the entire history of the galaxy into 1 year, the so-called cosmic calendar. If the Milky Way was formed on January 1st, then the first stars lit up in the first days of January. The Sun and Earth were formed approximately in early September. Life appeared on Earth in mid-September. Dinosaurs became extinct on December 26th. And the entire history of humanity from the first Homo sapiens to our days fits comfortably in the last few minutes of December 31st. We are a moment in the life of the galaxy, a flash of consciousness in the ocean of time. And the galaxy will continue to exist for billions of years after we disappear. But even 13 billion years is not the limit. The galaxy will evolve, change, transform. In 5 billion years, the collision with Andromeda will occur. In trillions of years, the last stars will go out. In unimaginably long time, in Google years, 10 to the power of 100, even black holes will evaporate thanks to Hawking radiation. And what then? What will remain of our galaxy, of all galaxies, of the entire universe? Nothing. Only cold, dark, empty eternity. The heat death of the universe. A state of maximum entropy in which nothing happens because there is no energy for anything to happen. This is the most frightening forecast of modern cosmology. The universe will not end with an explosion, it will end with silence, infinite, cold, empty silence. But this is still unimaginably far away. So far that these timescales have no practical significance for us. We live here and now in a young, active universe, full of light and energy. And this in itself is a miracle. Let's return to the question that worries many. Are we alone in the galaxy? Is there someone else there among these 200 billion stars and trillions of planets? This question is known as the Fermi paradox, named after the physicist Enrico Fermi, who once asked, "Where is everyone? If the galaxy is so old, if there are so many stars and planets in it, if life can arise naturally, then why do we not see any signs of other civilizations? Why is the cosmos silent?" There are many possible answers to this question, and none of them is comforting. Perhaps life is an incredibly rare phenomenon. Perhaps the emergence of even the simplest organisms requires such a unique combination of conditions that it happens only once per galaxy, or even less frequently. In this case, we may be the only intelligent civilization in the Milky Way, alone in a crowd of dead worlds. Or perhaps life arises often, but intelligent life rarely. Most planets with life may be inhabited only by microorganisms or simple creatures. The development of complex life, intelligence, technology are separate, unlikely steps, each of which can be an insurmountable barrier. There are also darker hypotheses. Perhaps intelligent civilizations inevitably destroy themselves. Nuclear wars, ecological catastrophes, artificial intelligence gone out of control. Perhaps there exists some great filter that destroys civilizations before they have time to go into space, and perhaps this filter is still ahead for us. Or perhaps civilizations are there, but they do not want to contact us. Perhaps they are watching us as we watch ants, with detached interest, but without a desire to enter into a dialogue. Perhaps there exists some galactic community to which we are not yet invited because we are not developed enough. Or perhaps the distances are simply too great. Even if thousands of intelligent civilizations exist in the galaxy, they can be separated by thousands of light years. Signals sent by one civilization will reach another in millennia. By then, the sender may no longer exist. The galaxy may be full of cries into the void, messages that no one will hear in time. We are looking for signals. The SETI program, the Search for Extraterrestrial Intelligence, has been scanning the sky for more than 60 years, listening for any signs of artificial radio transmissions. So far, we have found only silence. This does not prove that we are alone. Absence of evidence is not evidence of absence, but it makes one think. Perhaps the answer to the Fermi paradox is one of those that we do not want to hear. Perhaps the galaxy is silent because there is no one left to talk to, or because it is dangerous to talk, or because we are simply not smart enough to hear. Science does not give us an answer yet, but there is something strange and beautiful in the very fact that we can ask these questions. That we, tiny creatures on a tiny planet, are capable of looking at the stars and wondering if there is someone else there, that we can build telescopes and radio antennas, send probes to other planets, dream of interstellar travel. Even if we are alone, and that is a big if, the very fact of our existence makes the universe less empty. We are the way the cosmos realizes itself. We are the eyes and ears of the universe. And this is an incredible responsibility. Because if we disappear, if humanity destroys itself or is destroyed by a cosmic catastrophe, perhaps no one will ever know of the existence of the Milky Way galaxy. No one will look at the stars and wonder. No one will search for answers to the great questions. The universe will continue to exist, but it will exist without witnesses, blind, deaf, indifferent to its own splendor. And this is perhaps the strongest argument in favor of us preserving ourselves, not for our own sake, although that is also important, but so that the universe does not remain without observers, so that the beauty of the cosmos does not go to waste. We are the keepers of awareness, and this imposes obligations on us. Let's now dive into even deeper waters, into those areas of reflection where science intertwines with philosophy, where facts give birth to questions to which there are no answers. Because the true scale of our galaxy is not just numbers and distances. It is a challenge to our understanding of ourselves, our place in creation, the meaning of our existence. We have already talked about the fact that the Milky Way is only one of trillions of galaxies in the observable universe. But let's dwell on this in more detail, because this thought deserves deeper comprehension. Imagine that each galaxy is a separate world. Not a planet, not a star system, but a whole world containing hundreds of billions of stars, trillions of planets, quintillions of possible places where life could exist. And there are trillions of such worlds. 2 trillion, according to the latest estimates. Perhaps more. If you could visit one galaxy per second, instantly moving from one to another, without delays, without rest, it would take you more than 60,000 years to visit them all. 60,000 years of continuous travel at one galaxy per second. And each of these galaxies would require millions of years for full exploration, even if you could move at the speed of light. This is a scale that is impossible to realize. Our brain evolved to cope with the savanna, with hunting antelopes, with social relations in small groups. It was not created for the comprehension of infinity. And when we try to comprehend these numbers, our mind simply gives up, substituting instead of real understanding an abstract very many. But very many is not understanding. It is a surrender. Let's try another approach. Let's think about probabilities. If there are 2 trillion galaxies in the universe, and in each galaxy, on average, 200 billion stars, then the total number of stars in the observable universe is about 400 sextillion. This is a 4 with 23 zeros. More than the grains of sand on all the beaches of the earth, more than the drops of water in all the oceans, more than the atoms in your body multiplied by billions. And many of these stars have planets. According to modern estimates, practically every star in the galaxy has at least one planet. Many have entire planetary systems. This means that the number of planets in the universe may exceed the number of stars, 400 sextillion planets or more. And on some negligibly small fraction of these planets, conditions may be suitable for life. Liquid water, suitable temperature, a stable star, a protective magnetic field. Even if such conditions are met on only one planet out of a million, and this is probably an underestimated estimate, this still means 400 trillion potentially inhabited worlds, 400 trillion chances for life, 400 trillion possible stories, possible civilizations, possible beings looking at the sky and asking themselves the same questions as we. And with all this, complete silence. No signals, no signs, no evidence. This contradiction tears the mind apart. Either life is incredibly rare, so rare that we may be the only ones in the entire observable universe. Either something prevents civilizations from surviving, developing, getting in touch, or we fundamentally do not understand something about the nature of life, mind, and cosmos. Any of these answers is frightening. If we are alone, it means that the entire responsibility for the preservation of intelligent life in the universe rests on us. One civilization, one planet, one fragile spark of consciousness in the infinite darkness. And if this spark goes out, perhaps never and nowhere else will there be anyone who could look at the stars. If civilizations inevitably perish, it means that ahead of us lies some barrier, some catastrophe that we will not be able to survive. Nuclear war, climate change, artificial intelligence, a viral pandemic, an asteroid impact. The list of possible threats is long, and each of them is real. Perhaps right now the clock is already ticking, counting down the time remaining to us. And if we do not understand something, it means that our picture of the world, our science, our philosophy, all this may be fundamentally wrong. Perhaps life exists in forms that we cannot recognize. Perhaps intelligence does not necessarily strive for technology and expansion. Perhaps the universe is organized quite differently from what we think, and each of these possibilities forces us to reconsider our place in the cosmos. Let's talk about what physicists call the anthropic principle. This is the idea that the universe is such as it is because if it were different, we would not exist, and there would be no one to ask questions. This sounds trivial, but the consequences of this principle are deep and alarming. Look at the fundamental constants of the universe. The speed of light, Planck's constant, the gravitational constant, the mass of an electron, the strength of the strong and weak nuclear interactions. All these numbers have certain values, and if any of them were even slightly different, complex life would be impossible. If gravity were slightly stronger, stars would burn out too quickly, not giving life time to develop. If it were slightly weaker, stars would not be able to form at all. If the strong nuclear interaction were slightly different, heavy elements necessary for life would not be synthesized in stars. If the electromagnetic force were slightly different, atoms could not form molecules. The universe looks as if it is finely tuned for the existence of life, as if someone or something matched all parameters with incredible precision to create a cosmos in which consciousness is possible. This observation has troubled scientists for decades. There are several possible explanations. First is simply a coincidence. We were lucky. The constants turned out to be as they turned out to be, without any reason. This explanation is unsatisfactory because the probability of such a coincidence is vanishingly small, but it does not contradict any laws of physics. Second is intelligent design. Someone created the universe this way intentionally. This explanation goes beyond the boundaries of science and enters the field of religion and metaphysics. Science can neither confirm nor refute this hypothesis. Third, and perhaps the strangest, is the multiverse. The idea that our universe is only one of an infinite set of universes, each with its own laws of physics and constants. In most of these universes, life is impossible, but in some, including ours, conditions turned out to be suitable. And we, naturally, exist exactly in such a universe because we could not exist in any other. If the multiverse is real, then our galaxy is not just a grain of sand in the ocean of the cosmos. It is a grain of sand in one of an infinite number of oceans. Our universe is one of the countless attempts, most of which ended in nothing. and we are an incredibly rare success or an incredibly frequent failure, depending on how you look at it. These thoughts can cause dizziness. They may seem abstract and detached from everyday life, but they have practical consequences. If we really are rare, if consciousness in the universe does not occur often, then our responsibility for the preservation of this gift increases many times over. Every action that threatens our existence as a species, whether it be war, ecological destruction, or the irresponsible development of technology, becomes not just a mistake, but a potential cosmic crime. We do not have the right to extinction, not because our life is so valuable in itself, but because we may be the only carriers of awareness in an unimaginably vast cosmos, the only witnesses of this grandiose performance. But let's return to our galaxy and look at it from one more side. From the point of view of time and causality, light from distant stars and galaxies travels to us millions and billions of years. When we look at the Andromeda galaxy, we see it as it was 2.5 million years ago, because exactly that much time was required for light to overcome the distance separating us. At that time, our ancestors were not yet humans. They were Australopithecines, only beginning to master upright walking. When we look at distant galaxies billions of light years from us, we see the past of the universe. We see young galaxies, only forming, seething with star formation. We see quasars, the nuclei of galaxies in which supermassive black holes actively absorb matter. We see a universe that no longer exists. This means that we can never see the universe as it is now. We are always looking into the past. Even light from the sun reaches us in 8 minutes. We see the sun as it was 8 minutes ago. If it suddenly went out, we would find out about it only in 8 minutes. And for distant stars and galaxies, this delay is years, millennia, millions of years. We live in a bubble of the past, surrounded by information that is long outdated. And there are things that we will never see. Light from objects beyond the observable universe has not yet had time to reach us and will never reach us because space is expanding faster than light moves. There are regions of space that are fundamentally unreachable for us, not only physically, but even informationally. We are trapped in a finite horizon of knowledge. Beyond this horizon there may be anything, an infinite continuation of what we see, or something completely different. We will never know. This limitation is not technical. It cannot be overcome by more powerful telescopes or faster ships. It is a fundamental limitation sewn into the very structure of reality, a limit of knowledge established by the laws of physics. And our galaxy, our entire vast, immeasurable Milky Way, is completely contained inside this limitation. Every star that we see, every nebula, every cluster, all this is part of our small bubble of accessible reality. Beyond it is the unknowable. Let's talk about one more aspect that is rarely discussed, about the fragility of our position as observers. We are able to study the universe thanks to the fact that we are in a special place and a special time. Not in the center of the galaxy, where radiation would blind us, not on the outskirts, where there would be too little material for the formation of Earth-type planets, not too close to supernovas that would sterilize our planet, not too far from a stable star that provides us with energy. We live in an era when the universe is already old enough for heavy elements and complex structures to have formed in it, but still young enough for stars to continue to shine. In trillions of years, when the last stars go out, no life will be able to exist, at least not in the form that we know. We live in a brief moment of cosmic history when observation of the universe is possible. Before us were billions of years of darkness, the time of formation of galaxies and stars. After us will be trillions of years of fading, the time when energy dissipates and the universe cools. Our moment now is a window of opportunities that will not be open forever, and we are perhaps the only ones looking into this window. This thought should fill us with awe. We do not just live in the universe, We are part of the universe capable of realizing itself. Every question that we ask about the cosmos, every discovery that we make, is the way the universe knows itself through us. Astronomer Carl Sagan once said, "We are a way for the cosmos to know itself." This phrase is often quoted, but rarely meaningfully comprehended. We are not separate from the universe. We are its part. The atoms in our bodies were created in the depths of ancient stars. The oxygen we breathe, the carbon our bodies consist of, the iron in our blood. All this was synthesized in thermonuclear reactions billions of years ago. We are stardust having gained consciousness. We are the universe looking at itself. And when we study the Milky Way, when we measure its dimensions, investigate its structure, ask questions about its origin and fate, we are not just doing science, we are performing a cosmic function. We are doing what perhaps the universe created us for, or did not create us for, because perhaps there is no meaning in all this. Perhaps we are an accident, a byproduct of physical processes having no cosmic significance. Perhaps the universe does not want to be known. It has no desires, no goals, no intentions. It just is. And this is also a possible answer. This is also a worldview one can live with. But even if our existence is accidental, does that make it less amazing? Even if the universe has no goal, does that mean that we cannot give it meaning? We are the ones who ask questions. We are the ones who search for answers. And even if there are no answers, the search itself makes us who we are. Our galaxy does not know of our existence. Stars do not care if someone looks at them. Black holes are not interested in philosophy. The emptiness between galaxies does not experience loneliness. But we know, we care, we are interested and experience. In this is our uniqueness, in this is our burden and our privilege. We are consciousness in a universe that is perhaps otherwise devoid of consciousness. We are the light of understanding in the dark ocean of matter and energy. We are a rarity, maybe the only rarity of this kind. And our galaxy, for all its incomprehensible vastness, is our home. The only home we will ever truly know. The place where our whole history, all our hopes, all our fears unfold. 100,000 light years of sparkling stars shrouded in invisible dark matter, hurtling through the void to an unknown fate. And somewhere there, on the outskirts of one of the spiral arms, a small yellow star rotates, and around it a small blue planet, and on it we, looking up, asking questions, trying to understand. This is the story of our galaxy, not just a story of dimensions and distances, not just a story of physical processes and cosmic catastrophes. This is a story of awareness, a story of how a part of the universe learned to see the whole. And this story is not yet finished. We continue to look, continue to search, continue to be amazed. Each new discovery is a new chapter. Each launched telescope is a new eye directed into infinity. We do not know what we will find. We do not know what secrets the cosmos still hides. But we know one thing. We will continue to search because that is what we are. Because that is what we are here for, maybe. Or maybe we are here for nothing at all. And that is also fine, because even without a goal, even without meaning, even without a cosmic destiny, we can still look at the stars and feel awe. We can still ask questions and search for answers. We can still love, dream, create. And this is perhaps the most amazing of all. We have come a long way together, from the first shocking numbers to deep philosophical reflections, from the scales of our galaxy to questions about the meaning of our existence. Now the time has come to gather all the threads together and look at the full picture of what we have learned. Our galaxy, the Milky Way, is a structure with a diameter of 100,000 light-years of visible matter and more than 1,000,000 light-years if the invisible dark matter halo is taken into account. It contains from 200 to 400 billion stars, each of which is a whole world with its own history, its own planets, its own possibilities. It rotates, evolves, absorbs smaller galaxies, and prepares for a grandiose collision with Andromeda in 4.5 billion years. And with all this, it is only a grain of sand in the cosmic ocean. We talked about the emptiness between stars, about trillions of kilometers of absolute nothing separating each pair of neighboring luminaries. We talked about black holes, invisible monsters warping space and time itself, absorbing everything that approaches too close. We talked about supernovas and gamma-ray bursts, catastrophes of such power that they can sterilize entire regions of the galaxy in a matter of seconds. We talked about dark matter and dark energy, about the fact that 95% of the universe remains a mystery to us despite all our scientific achievements. We talked about the expansion of the universe, about how distant galaxies forever disappear beyond the cosmic horizon, carried away by expanding space. We talked about heat death, about the distant future when the last stars will go out and the universe will plunge into eternal darkness. And we talked about ourselves, about our place in this grandiose picture, about our fragility and our uniqueness, about the questions to which we have no answers, and about the search that we still continue. Now let's try to comprehend all this together. The first thing that becomes obvious is our absolute insignificance in the physical sense. We are nothing, a speck of dust on a speck of dust in an infinite ocean of specks of dust. Our planet is a dot, our star is a spark, our galaxy is a drop. And all this is lost in the boundless expanses of the cosmos like a tear in the ocean. If humanity disappeared tomorrow, if some catastrophe destroyed all life on Earth, the universe would not notice this. Stars would continue to shine, galaxies would continue to rotate, black holes would continue to absorb matter, the cosmos would continue to expand, nothing would change, nothing would stop, nothing would mourn our death. This knowledge can be destructive. It can cause despair, depression, existential horror. Why do anything if we are so insignificant? Why strive for anything if everything will ultimately be absorbed by emptiness? Why live if life has no cosmic significance? But there is another way to look at this. Our insignificance in the physical sense does not mean our insignificance in the sense of meaning. Size is not the only measure of value. Duration is not the only criterion of importance. That we are small and short-lived does not mean that we are meaningless. Look at it from the other side. In all this unimaginable greatness of the cosmos, in all these trillions of galaxies, quadrillions of stars, sextillions of planets, we have not yet found any other place where consciousness exists, not a single other example of how matter organized itself so complexly that it began to be aware of itself. Perhaps such places exist. Perhaps there are billions of them, but we do not see them. We do not hear them. So far, we are the only thinking beings known to us in the universe, and this makes us infinitely rare, infinitely valuable. Not in the eyes of the cosmos. The cosmos has no eyes, but in our own eyes, in our own understanding. We are a rarity. We are a miracle. We are an impossibility having become possible. Think of what was required for our appearance. First, the Big Bang, which created space, time, matter, and energy. Then billions of years of expansion and cooling, the formation of the first atoms, the first stars, the first galaxies. Then generations of stars, living and dying, synthesizing heavy elements in their depths and scattering them in space during supernova explosions. Then the formation of our sun, from a cloud of gas and dust remaining from previous stars. The formation of the Earth from the same material, billions of years of geological and chemical evolution that created the conditions for life. The appearance of the first self-replicating molecules, evolution from simplest cells to complex organisms. Millions of years of primate evolution, hundreds of thousands of years of human evolution. And here we are, the product of 13 billion years of cosmic history. Beings capable of realizing this history and asking questions about it. Every atom in your body was created in a star. Every molecule is the result of billions of years of chemical evolution. Every cell is but an inheritor of 4 billion years of biological evolution. You are not just a person, you are the culmination of a cosmic process of unimaginable complexity and duration. And you are capable of understanding this. This is perhaps the most amazing of all. The universe created a being capable of realizing the universe. The cosmos gave birth to an observer capable of comprehending the cosmos. Matter organized itself into a structure capable of asking questions about the nature of matter. This is not just amazing, it borders on a miracle. And it does not matter if it was planned or accidental, the result is equally striking. Let's return to our galaxy and look at it with these new eyes. The Milky Way is not just a cluster of stars and emptiness. It is a place where something incredible happened. Somewhere here, in one of the spiral arms, on one of the trillions of planets, matter awakened, began to think, began to ask questions, began to search for answers. Perhaps this happened only here, on Earth. Perhaps this happened in thousands of other places that we do not know about. But even if we are alone, our galaxy is still the birthplace of consciousness, the place where the universe first opened its eyes and saw itself. This gives the Milky Way a special significance, not in the physical sense. Physically, it remains an ordinary spiral galaxy, unremarkable. But in the sense of meaning, it becomes the cradle of something unique, the place where the story of awareness began. And we are part of this story, not the main hero. The story has no main heroes, but participants, witnesses, those who look and are amazed. When you lift your eyes to the night sky and see the glowing band of the Milky Way, that very band that our ancestors saw thousands of years ago, you are looking at your home, at the place where you were born, grew up and will probably live your whole life in 100,000 light years of stars, gas, and secrets. And yet you are looking into the past. Light from these stars traveled hundreds and thousands of years to reach your eyes. You see the galaxy as it was when people had not yet invented telescopes, had not built cities, had not thought about space. In a way, by looking at the stars, you are performing a time travel. You see the past with your own eyes. You touch the history of the universe directly without intermediaries. This is accessible to everyone. This is free. This happens every clear night, and most people pass by without noticing, without thinking, without being amazed. But you now know, you understand what you see when you look at the sky. You realize the scale of what is out there, beyond our atmosphere. And this knowledge changes everything. Let's talk about what this knowledge means for our everyday life. Many people, for the first time realizing the scales of the universe, feel overwhelmed. They think, if I am so small and insignificant, then what is the point of all this? This is an understandable reaction. Our mind evolved to cope with problems of the human scale, with hunting, with social relations, with survival in the savannah. It was not created for the comprehension of infinity. But there is another reaction, and it is perhaps healthier. If we are so small and short-lived, then every moment of our existence becomes infinitely valuable. Every breath is a miracle. Every sunset is a gift. Every conversation with a close person is an event of cosmic importance, because such events are so rare in the universe. The realization of our fragility cannot oppress, but liberate. Liberate from petty worries, from empty anxieties, from unnecessary fears. When you understand that all this, all our life, all our civilization, all our planet, is but a moment in cosmic history, many things cease to seem important. Quarrels, offenses, envy, anger, all this becomes ridiculous against the background of eternity. Why spend your short time on negativity when you can spend it on amazement, on love, on knowledge? This does not mean that one must become indifferent to earthly affairs. On the contrary, it means that one must choose what to spend one's limited time and energy on. Choose consciously, understanding the scale and context, and choose what is truly important. What is truly important? This is a question everyone must answer for themselves. But there are some things that seem important from the cosmic point of view. First is knowledge, understanding of where we are and what surrounds us. Science is not just a way to create technology, it is a way to comprehend the universe. This is our cosmic function, if you will. Second is preservation. Preservation of our species, our planet, our knowledge. If we are the only conscious beings in the galaxy, then our survival becomes a question of cosmic importance. We do not have the right to extinction until we make sure that somewhere there are others who will continue our work. Third is expansion. If we want consciousness to survive in the long term, we must spread beyond the Earth. One planet is too fragile an ark, an asteroid, a supervolcano, a nuclear war. Any of these catastrophes can put an end to everything. To truly secure ourselves, we must become an interplanetary and ultimately an interstellar species. And fourth is connection. Connection with each other, with other beings on our planet, possibly with other civilizations if they exist. We are social beings. Our consciousness developed thanks to interaction with others. If we want to continue developing, we must continue communicating, cooperating, learning from each other. These four things, knowledge, preservation, expansion, connection, can become our cosmic mission. Not in the religious sense, no God assigned us this mission, but in the sense of a self-chosen goal that gives meaning to our existence. We can choose to be the ones who know the universe, the ones who preserve the spark of consciousness, the ones who spread it across the galaxy, the ones who search for others and try to understand them. This is a worthy goal, a goal that goes far beyond our individual life and even beyond the life of our species, a goal that connects us with the past and future of the universe. But let's be honest, most of us will never fly into space. Most of us will not make great scientific discoveries. Most of us will live an ordinary life on an ordinary planet, doing ordinary things. And this is also fine, because every life, regardless of how ordinary it is part of the cosmic story. Every person is a product of 13 billion years of the evolution of the universe. Every conversation, every thought, every emotion is an event in a cosmos that is predominantly dead and empty. When you laugh, the universe laughs. When you love, the universe loves. When you ask a question, the universe asks a question of itself. You are not just in space, you are part of space, inseparable, integral part. And everything you do is part of what the cosmos does. This may sound mystical, but it is just physics. The atoms of your body were created in stars. They obey the same laws as all other atoms in the universe. Between you and a distant galaxy, there is no fundamental boundary. There is only distance and time. We are all one whole. Separated by space, but united by physics, separated by time, but united by history, separated by consciousnesses, but united by a common origin. And when you look at the stars, you look at your relatives, distant, unlike, unreachable, but relatives. We all came from one source. We all are manifestations of the same universe. Now let's complete our journey. Let's return to what we started with, to our galaxy, to its true dimensions, to our place in it. The Milky Way is huge, so huge that we can never truly realize its scale. 100,000 light-years is a number that we can say but cannot feel. 200 billion stars is an amount that we can write down but cannot imagine. And yet the Milky Way is but one galaxy out of trillions. One drop in the ocean, which itself is but a part of something even larger. We do not know what lies beyond the observable universe. We do not know if there are other universes. We do not know if the cosmos is infinite or finite. We know almost nothing. And this, strangely enough, is beautiful. because it means that there are still so many discoveries ahead, so many mysteries waiting to be solved, so many questions waiting for answers. We are not at the end of the road, we are at the very beginning. Humanity as a species has existed for about 300,000 years. Science in the modern sense for about 400 years. We have only begun to know the universe. We are like an infant who has just opened its eyes and is trying to understand what it sees. What will we learn in 100 years, in 1,000, in 1,000,000? If we survive, if we preserve ourselves as a species and continue to develop, horizons will open up before us that we now cannot even imagine. Perhaps we will find others. Perhaps we will understand dark matter and dark energy. Perhaps we will learn to travel between stars. Perhaps we will create new forms of life and consciousness. Perhaps we will become something completely different, something that our ancestors could not have understood. Or perhaps we will destroy ourselves. Perhaps we will never get off this small planet. Perhaps in 1,000 years nothing will remain of humanity but a few radio signals flying into the void. We do not know which scenario will be realized. This depends on us, on our decisions, on our wisdom, or its absence. But one thing we know for sure, right now, in this moment we exist, we think, we feel, we look at the stars and wonder, and this is already a miracle. Our galaxy hurtles through the void at a speed of more than 2 million kilometers per hour. The sun rotates around the galactic center, completing one revolution in 230 million years. The Earth rotates around the sun, completing one revolution in a year. And we, small, fragile, mortal, live on this rotating planet, around this flying star, in this rushing galaxy. We are travelers even if we go nowhere. We are explorers even if we do not leave our home. Simply by existing, we participate in the most grandiose journey that can only be imagined. And when you close your eyes tonight, when you begin to fall asleep, perhaps still thinking about stars and galaxies, remember this. Remember that you are not just lying in your bed. You are flying through space. You are part of the universe realizing itself. You are a miracle that should not have happened, but happened. And let this knowledge accompany you into the world of dreams. Good night, traveler. Good night, stardust. Good night, fragment of the universe. The stars will shine for you while you sleep. The galaxy will rotate. The cosmos will expand. And when you wake up, all this will still be there. Huge, incomprehensible, beautiful, waiting for you to look up and wonder again. Because wonder is the beginning of wisdom. And while we are capable of wondering, we are alive truly. Sleep peacefully, the universe will take care of itself. It did this for 13 billion years before your birth. It will do this for trillions of years after. And we will continue to look, continue to ask, continue to search, because that is what we are. That is why we are here, or at least that is what we chose. And that is enough. That is more than enough.